ongoing activity of a report that has been issued hearing from two presenters at this time. May I invite Peter to say these things, then that.
Can you increase the volume?
So there will be a joint presentation that have this program. It's a joint presentation.
I've connected the laptop. It's not on. So please increase the volume here and I turn it on, okay?
Okay, so I will begin with the history of pesticide use in Ghana and would zero into neonicotinoids and their use in pest control in Ghana. I would also talk about some residues of neonicotinoids within the Ghanaian environment and some outlooks and implications for the use of neonicotinoids and other systemic insecticides in crop production. So this here is an overview of pesticide registry in Ghana as at 30th December 2015. And although this may have been revised, and I'm sure it has, the general constitutions are largely the same and dominated by herbicides and insecticides, with fungicides playing a minor role. But let me just say that these are the pesticide formulations and not necessarily the active ingredients. In terms of the history of pesticide use in Ghana, it tends to mirror that of synthetic pesticide production worldwide. So we began with chlorinated hydrocarbons and the era of DDTs and lindane and so on, and which was followed by organophosphates, because of the persistence of these. Organophosphates were less persistent, but were found to be much more harmful to humans. And we did have the methyl carbamate and pyrethroids, and followed by the systemic pyrethroids coming in that era. And then in the 1990s, we had the introduction of a new class of insecticides, the neonicotinoids. And since the 1990s that they came into power, onto the insecticide market, several of these neonicotinoids have been produced. But the very first was imidacloprid. And they are referred to as neonicotinoid because of the similarity of their structure with nicotine. So neonicotins, and that's their name. So imidacloprid came out and since then number of other companies have produced other neonicotinoids. In Ghana we do have imidacloprid, thimeritoxam, and acetamiprid being registered for use in the country. Now, what's peculiar about these is the fact that they usually have at least one ring system, usually pyridine, thiazolidine, and so on. And more importantly, they often have strong electron withdrawing groups. Okay, and usually these are nitro or cyano groups, and they are very important for their action. They also help in their water solubility. Now, this strong electron withdrawing group enables their action as agonists on the post-synoptic nicotinic acetylcholine receptors, and that's how they act to effect their action. And they do this with remarkable selectivity. So they are very, very toxic to invertebrates, but very low toxicity to humans, and with also very low log P values. These log P values suggest that the low log P values makes them much more water soluble, and therefore they are effective plant systemic insecticides. So once you apply them, they can get into the plant, where they stay within the plant and provide long-term protection against insect pests. As well, neonicotinoids have a diversity of application techniques. So they can be applied as foliar sprays, as seed treatment, soil drenches, and so on. And this has enabled its use in virtually in more than 120 countries worldwide. So in more than 120 countries, they are registered and they are widely applied, currently the most widely used class of insecticides. However, this large use has also been associated with high exposure within the environment. And as well, and even more importantly, is the fact that the long-term decline in bee populations have been linked to the adverse effects of neonicotinoids. So in Europe, for instance, there has been a ban and restriction in the use of neonicotinoid insecticides. And these are these were based on recommendations by USAG and EFSA on the harmful effects of neonicotinoids. Now let's come home to Ghana. In Ghana's cocoa production, we produce the world's best cocoa, and that is not in doubt. Again, cocoa production is really, really important to the economy of Ghana, and each year we generate close to $2 billion in terms of foreign exchange annually. And based on this theme of addressing food security and poverty alleviation, there's no single crop that is much more important than cocoa in the economy of this country. Again, it tends to employ close to about 800,000 farm families, and with an average size of about 5 persons in a family, that's about 4 million 4 million persons being employed within the cocoa industry. So it's really, really important to the economy of Ghana. One of the big challenges that we've had in cocoa production, however, has been pests and diseases. And according to the International Cocoa Organization, at a workshop that they had here in Accra, it was suggested that pests and diseases account for up to about 40% yield losses annually. So that is a huge problem. And the major ones are merits, which are the insects that destroy cocoa. We also have the black pod disease, which is the fungal disease, as well as the cocoa swollen shoot disease. And this disease here has been very devastating, for the cocoa industry in Ghana, because once they attack, you just have to cut off the cocoa trees and then replant. So faced with this challenge, as well as the use of sometimes unapproved pesticide on cocoa farm, the government in 2001 decided on a program which they refer to as the Cocoa Disease and Pest Control Program. And under this program, which now we popularly call mass spraying, and those of you in Ghana would have heard about cocoa mass spraying, insecticides are sprayed, or pesticides in general are sprayed on cocoa farms at no direct financial cost to farmers. So farms are sprayed for free, or these insecticides or pesticides are given to farmers to use on their farms. And in effect, it helped ensure that we're using the right kind of the approved pesticide by Cocoa Board, so that the farmers don't use other pesticides that may not be approved. Good. And neonicotinoids are very important in this exercise, because we apply this class of insecticides, these three that we mentioned in cocoa, to control these diseases and pests here. Now, since the introduction of this exercise, there has been great or substantial increases in yield. But I must say that this is not just based on the pesticide application. A number of interventions are currently underway. Through by Ghana Cocoa Board, through seed improvement, the use of improved seed varieties, the use of fertilizers, and we might have heard that from the Minister of Agric yesterday. So a lot of interventions have gone into increasing the levels, and since the start of the Kodapec program, we have less than 400,000 metric tons, and now we are hovering at least average in excess of 800,000 metric tons. And this is value to the farmers. This is more money for the economy and helping for alleviate poverty. However, we also looked at the levels on the residues of these neonicotinoids within the Ghanaian environment, and here we analyzed these levels in soils and then in cocoa beans mainly, and then we also looked at the fate within the soils. Now, the Cassius procedure was used together with liquid chromatography tandem mass spec, and this was done in the MRM mode. And extensive method validation was undertaken to ensure that the results were reproducible and all of that. Now, this is just a summarized view of the results. And in here, in the soils that we looked at, and we looked at about 52 different soils from the various regions of the country, imidacloprid mirrored its use in being the predominant neonicotinoid found in cocoa soils, and up to about 75% of the samples had some levels of neonicotinoids. Again, we found clothianidin, which is not approved for use in Ghana. However, its presence, it's not strange, because thiamethoxam is approved, and clothianidin is a breakdown product of thiamethoxam in soil. And since within the soils, once we're finding that, it wasn't too strange. Again, we looked at the levels in cocoa beans itself, and here as well, we went through extensive method validation and optimization to ensure reliability and reproducibility of these results. So I won't bore you with all these details, but these are the results that we found. In terms of results, we separated the beans, the actual beans, which we refer to as the cocoa nibs, from the shells, because in producing cocoa, the shells are separated from the beans itself, which we call the nibs, in making chocolates and cocoa products. So we separated them and analyzed them differently. The levels that you see in this color, orange or brown, refers to that of the shells,
and the blue are the cocoa nibs. But so let's take the cocoa nibs, and you realize that almost all of them, the highest was about 40 nanogram per gram or microgram per kilogram, and these were well within the acceptable, at least EU limits, which usually have the stricter limits. However, the shells had quite high levels, and for each, what we have here is the level within the nib and the shells. What was clear was that the pesticides were accumulating in the shells. So perhaps a way in which nature decontaminates the edible portion of the cocoa, but clearly there were relatively high levels within the cocoa shells. Lastly, we looked at the fates within the cocoa environment, the soils, because soils are an important sink for these pesticides. Almost all that we apply ends up getting into the soil. And again, we've talked about the water solubility and the low log P values of these pesticides. So we looked at their degradation and sorption within soils, and here they were studied using established kinetic isotherms and standard methodologies. So here, in studying degradation, they were split into various homogeneous samples, hundreds of them, and then they were incubated at 25 to 26 degrees Celsius, which was the temperature that we found in the cocoa ecosystems under the forest conditions. And these were studied for close to a year under laboratory conditions. We also used established kinetic isotherms, 3 of them, to look at the degradation of these within soils. So just to the results, we found out that for imidacloprid and thimethoxam, which were the 2 insecticides that were studied, their half-lives were in excess of 150 days. It means once applied, it takes at least 150 days for the levels to reduce to half of the original amount that is present. So this is imidacloprid, and just to ensure reproducibility, we used its deuterated product as well, and this is for thimethoxam. In both cases, more than 150 days within soil, showing the likelihood of persistence within the soils. We also looked at sorption, and we looked at sorption on about 5 different soil types, 4 different soil types in different concentrations, and based on the results, so these were the various characteristics of the soils that we looked at. Based on the results, we realized, and that really agrees with literature, that they had very low sorption coefficients. So they are not likely to be sorbed into the soil. They are more likely to remain within the water, the aqueous phase, and this increases their tendency for mobility within the soil environment. Again, desorption, we tried desorption. After they are sorbed onto the soils, what happens? Are we able to get them back? Desorption were also quite low, and there was evidence of hysteresis present within the soils. So just you don't have to bother about these, but clearly what was clear was that they have low sorption coefficients, and all of them, they fitted very well on the French isotherm. And lastly, the fact that organic matter was really important in determining their absorption onto soils. Now, these are a summary of the findings that we have. So neonicotinoids, they tend to have widespread exposure in the environment. We found them in the soils, in some of the cocoa matrix, and all of that. Again, they may likely be persistent in soils, and let me just say that this was based on under lab conditions, and the real field may or may not be exactly the same. Again, sorption was very low and presents a high possibility for leaching into underground and surface water, and also the fact that they could have a tendency to accumulate within food or soils if we apply them at high application rates. Now, these are some perspectives based on the study that possibly they appear to be low efficiency in terms of the pesticide usage. Probably we may be applying much more than might be needed by the crops, and hence the excess within the soils and the environment. And this has implications for costs. So perhaps we could reduce costs and help the environment if we are to apply it in a more efficient manner. And again, our focus is increasing yields of cocoa, and that is wonderful because, and that's the intensification of agriculture that we're talking about. However, we also have to ensure that the environment is protected in our quest to maximize the amount of crops that can be produced within a particular area of field. And lastly, inefficiencies pose significant challenges and risks to ecosystem services, including pollination, natural pest control, nutrient recycling, and that has also been established from the literature. So it's quite clear that in order to ensure food security and poverty alleviation, we really need to rely on sustainable agricultural practices, and this, I believe, will be underpinned by ensuring that biodiversity is conserved and that appropriate ecosystem functions are in place. I would like to end with this slide, beyond neonicotinoids, because here we are looking at neonicotinoids in general, and I'm sure Nina will tell us the bigger picture of neonicotinoids, not just in Ghana, but in the rest of the continent. Neonicotinoids are, so this is imidacloprid being used, for instance, as an example of neonicotinoids, but there are other systemic insecticides which are currently being produced, and we probably might move from one to the next. So, for instance, we may move from imidacloprid to sulfoxaflor, okay, or we might move to FPF, and all these are coming up and they are available. They all target the same nerve site as neonicotinoid does, only that, of course, the manufacturers determine the name and they won't call any of these neonicotinoids. We won't if we were manufacturers. They determine the various classes and how to call them. But it's important that we consider and especially and apply some of these strict measures that we are looking at with neonicotinoids to these, in order not to make the mistake that we have with neonicotinoids. So with this, I would like to say thank you and to appreciate Danida through the BSU project for sponsoring and part of this project, and then the University of Ghana. So thank you so much.
Thank you very much.
Yes.
Ladies and gentlemen, it is my great honor and pleasure to present to you today this report on neonicotinoid insecticides, their use and effects in African agriculture. This report is the result of a joint effort of European and African science academies who have worked together for over a year under the general leadership under the general leadership of in the framework of the Inter-Academy Partnership, and with particular support of NASAC, the Network of African Academies of Science. There we go. The starting points for this project, as Enoch already shortly outlined, was the increased market penetration of neonicotinoids since the 1990s and an increasing awareness of the importance of ecosystem services for agriculture. Ecosystem services have been valued from an economic perspective in the IPBES report, who came up with numbers of 153 billion euros annually for pollination worldwide and 91 billion euros annually for natural pest control. So it's worth the effort to save ecosystem services. In addition, there was increasing evidence of the harmful effect of neonicotinoids on ecosystem services in many studies conducted in Europe and in North America, and these have led to bans of neonicotinoids in Europe since 2018. The question arose then what is happening in Africa, whether there is also this situation that older pesticides are being replaced by neonicotinoids and whether neonicotinoid use is expanding. And the question was how to best evaluate the situation in Africa, what is the current status and what are the trends. Here we go. I want to look back to the evidence that led to the bans of neonicotinoids in Europe. The first large piece of evidence was that the prophylactic use of neonicotinoids, so the use in the absence of actual pest infection, has severe negative effects on non-target organisms, which provide important ecosystem services such as pollination and pest control. The second piece of evidence is that there is clear evidence of sublethal effects of neonicotinoids. So the insects may not die immediately on contact, but honeybees, for example, they're particularly well studied, suffer from reduced learning ability, reduced orientation ability, reduced foraging efficiency. They don't live as long, and you can imagine how these effects scale up to the health of an entire hive. In addition, even at very low levels, neonicotinoids can severely harm the health of bees to a point where latent viruses and other parasites and parasitoids can additionally affect bee health. And it is very important to consider that the large-scale preventative use of pesticides, even only against secondary or occasional pests, is in direct contraventions to integrated pest management and sustainable agriculture. In integrated pest management, chemical control of insect pests is really just a last-ditch effort, whereas in the prophylactic use, it is the first thing that is being done without necessarily having an infection. The workflow of this project started from the ESAC report from 2015 on ecosystem services, agriculture and neonicotinoids, and with the help of NASAC and its African member academies, we put together 2 working group meetings in Pretoria and Nairobi, and supplemented the knowledge gleaned there from the African experts with an extensive literature review, resulting in the report that you're holding in your hands and that was only published 2 days ago. There we go. In terms of geographical scope, we involved experts from 17 African countries, and then by adding the literature review of all published literature on neonicotinoids, we increased coverage of African countries to 28. The picture of the current situation that emerged from this review and the working group meetings is that all countries appear to be using neonicotinoids and that older pesticides are indeed being replaced by neonicotinoids, but market penetration is at an earlier level than in Europe, and the overall pesticides consumption of Africa is actually only just a fraction of global pesticide use. However, Africa is flagged as the largest and fastest growing market for pesticides and particularly insecticides in recent market surveys, and there is already evidence for the use of very intensive techniques such as the use of dressed seeds, as you can see in this usage map in South Africa. And so The concern stemming from the bans of neonicotinoids in Europe was that pesticides manufacturers would try to expand their market in Africa, pushing to either replace older pesticides or increase rates of use in Africa. And so the working group considered it timely to have a look at whether the concerns that arose over the neonicotinoid usage in Europe also apply to Africa. When assessing the implications of previous work on pollinators and other ecosystem service providers to an African context, the first and most important realization is that the basic toxicology of neonicotinoids is unlikely to be different, and there's already evidence emerging from Africa that this is indeed the case. African pollination systems and pollinators are different. African bee species are managed in a different manner, and the challenge is that Africa has this incredibly rich biodiversity and ecosystems, but they're not yet all studied and documented very well. And so in the course of this project, we realized early on that it would not be possible to actually quantify the trends in pollinating insects and ecosystem services for Africa in the time span of this report. And so that meant that we relied on the expert evidence as well as the published literature. Now looking and comparing African ecosystems, we looked at the economic vulnerability to pollinator loss of African countries, so the costs that would arise from losing pollinators and having to find other means of increasing fruit set, and found that North and West Africa actually have very similar economic vulnerability to Europe. Pollination systems in Africa involves a tremendously large number of species from different taxonomic groups. It goes far beyond honeybees and includes other bee species, wasps, a large range of flies, butterflies, moths, beetles, birds, you name it. There are, of course, more honeybee colonies in Africa, and African beekeepers often rely on capturing and restocking their hives from the wild. In Europe, the situation is that most hives are owned and they live in boxes. The problem arising from having largely wild colonies is that these cannot be moved out of harm's way if pesticides are being applied, and so the wild bees might actually be in greater danger from pesticide application. And it is also very important to consider globally that honeybees are not the most efficient pollinators for a large number of fruits. Instead, a range of other pollinators, of smaller pollinators occurring in smaller colonies, make an important contribution to pollination, and therefore measures to protect only honeybees is insufficient to protect ecosystem services. Looking at ecosystem services from the angle of contamination, our report documents that neonicotinoid contamination is widespread, mostly with imidacloprid, and there is residues in pollen and honey that are as high as, or sometimes higher, as levels were in Europe before the bans were imposed there. Studies have also confirmed the contamination of soils. We just heard it from Enoch, with varying levels, and some of them very high. And an ongoing study at Ichipe in Nairobi is showing that also watercourses are being contaminated and are affecting the insects and other organisms living in water bodies. Looking at the effects on birds, the working group experts agreed that there are declines in honeybee populations. This can be seen from decreases in wild populations. There's fewer migratory swarms. There's disappearance and loss of hives. There's stories about mass bee mortalities and reduced honey production. But also other insect species of commercial value, which are the ones that are most visible, that receive most attention, such as edible crickets, are declining, as are insectivorous birds. Neonicotinoids are also used quite copiously in cocoa, as Enoch discussed just now, and they're there is a suggestion that neonicotinoid use has actually caused cases where there was a proliferation of secondary pests and a reduction in pollination by the natural pollinators of cocoa, the midges, because of this practice. And another piece of evidence for widespread use of neonicotinoids comes from the appearance of resistance to these pesticides, mostly in aphids and whitefly pests from now, but also in urban insects because neonicotinoids are used for indoor residual spraying. The report also looks at the available research capacity to address these issues in Africa, and came to the conclusion that there are many research groups, some governmental, some institutional, that are undertaking a wide range of research on neonicotinoids. There are some global centers of excellence, such as the International Center for Insect Physiology and Ecology in Kenya. But overall resources are very limited and some disciplines are underrepresented. And of course, the resources are widely distributed over Africa, bringing with it significant challenge in terms of coordination. And so what is really needed is mechanisms to strengthen the synergies between the available resources. The report also looks at regulation and enforcement, and concludes that regulation on agricultural pesticides exists in almost all countries, but the problem is that compliance and enforcement are often weak. Regulatory procedures often tend to rely on data from outside Africa, for example from the EU, the US, FAO, etc. But the recent EU restrictions on neonicotinoids are not yet being followed or are only under consideration in very few countries. Because of its rich diversity, it makes sense that in African countries regulations should remain country-specific, but it is very important to have jointly agreed upon science-based and binding criteria underpinning authorization measures based on the precautionary principle. An additional problem is that regulatory systems also make no specific provisions for pollinators, so they're not necessarily involved in testing schemes, and that honeybees particularly, and pollinators in general, are not placed in the correct legislative framework, so that there is actually no legal mechanism to protect them, and they fall through all the cracks. Looking at extension services, all experts in the workshops agreed that the role of extension services is overall poor, particularly for smallholder farmers. And farmers are typically unaware of the environmental or health hazards associated with pesticides use. So extension services are urgently needed and should focus on the dissemination of good agricultural practices. Importantly, to provide education about ecosystem services and to create awareness that not all insects are pests, but that some of them provide very important beneficial services. Farmers and pesticide operators need to be better educated about the effectiveness of insecticides, and extension services should really emphasize the importance of integrated pest management and disencourage preventative and prophylactic use of pesticides. So with that, I come to the conclusions and key messages of this report. The report concludes that the sustainability of African agriculture is critical to food security and for maintaining its contributions to African economies and supporting rural communities. Biodiversity, crucially, underpins ecosystem services and provides resilience to other influences such as climate change and other environmental pressures, and it is therefore important to maintain this biodiversity. It is very essential to apply the knowledge that has already led to restrictions on the use of neonicotinoids in Africa. There is evidence already emerging in Africa from loss of honeybee colonies, contamination of agricultural products in soils and in freshwater systems. So there is definitely cause for concern and a need for action. Neonicotinoid usage in Africa is currently less than what used to be used in Europe. So there is a window of opportunity to learn from what other countries have already experienced before the losses and the damages in Africa become too large. There is an urgent need to reduce the tensions between agricultural intensification and Africa's rich and abundant biodiversity and ecosystem services. There is a need for stricter regulation of insecticides across Africa, and a precautionary approach needs to be developed on the basis of existing scientific evidence showing the negative effects of neonicotinoids on insects and ecosystem services. Good agricultural practices should be promoted, and African regulatory systems might benefit from taking a closer look to the regulatory reviews already being undertaken elsewhere. To strengthen food security within a sustainable agricultural systems, countries should strengthen their expertise and the extension services to disseminate knowledge and methods of IPM. And importantly, this needs to be done in a manner that is independent from pesticides manufacturers, suppliers, and traders. And lastly, no, not quite lastly, and international funding agencies and national governments should substantially strengthen the provision of research, advice, and training on sustainable agriculture. Looking forward, the report emphasizes that there is an important opportunity to act now on the existing knowledge about the harmful effects of neonicotinoids to protect ecosystem services, African biodiversity, and agricultural sustainability. The report that you're holding in your hands is meant to be a valuable resource to inform further scientific and political engagement on these issues and to develop solutions at the national and the regional level. As Enoch also emphasized, it is also important to not focus narrowly on those neonicotinoids that are currently registered, but to ensure that the substances replacing them that have a similar, if not identical, mode of action do not have the same negative side effects that neonicotinoids currently have. And lastly, it is important to be aware that African science academies can play an important role in both the scientific and the advisory process through the academic excellence of their membership and networks, their convening power, and their established collaborations with policymakers. And with that, I thank you for your attention, and I acknowledge the German Federal Ministry of Education and Research and the South African Department of Science and Technology for funding this project. Our many partners in crime in putting together this report, the Network of African Science Academies and its member academies, who have provided excellent nominations for the working group members. The Academy of Science of South Africa has taken a leadership position on this project within Africa, and we are very grateful for that. And there is a number of other bodies and networks involved. Of course, huge thanks goes to the experts that have joined our working group meetings, that have commented on drafts, have provided inputs in literature, and have made it possible to really put together this report, which is the first of its kind and collates more information than has ever been collated for Africa on the current status, gaps, and paths forwards. And with that, I would now like to thank you again and lead over to a panel discussion on these issues. And I would like to invite the panelists who are sitting in the audience to please come and join us here in the front.
You wanted to ask a question. Yes, I want to. Why don't you?
Thank you very much for this excellent presentation. At the very beginning,
Thank you, Prof. So, well, for neonicotinoids, the major reason
Yes, that's right.
and the
Would you
major
like to sit on the other side of the panel,
idea that
or
led to their discovery
it would be
was
good if I could
the
sit here?
development of resistance.
So,
Okay.
is
the
that okay
fact
with you?
that,
Okay.
you know, as you mentioned, organochlorines have linked with persistence, and organophosphates, methyl carbamates, and so on came to replace them, but they were more toxic. What neonicotinoid had was the fact that it is targeted at different nerve sites. So the NHs that it was targeting, it's very different from all the other classes of insecticides that have happened before. And again, the fact that it was very selective in terms of its targets. It was very toxic to insects, but low toxicity to vertebrates. So for humans, it was really good. It was at the time that it came out, it was seen as the ideal insecticide, because it was seen as not being too persistent and less toxic to humans. Although later we found out that it was having these effects on other non-target organisms, including bees. And one of the reasons why we couldn't find them from the beginning was the fact that they often had sublethal effects. They may not kill the bees instantly, so you wouldn't find mortality right at the beginning, but they had sublethal effects. So they impaired their reproduction, they impaired their coordination or their navigation, and if the bee cannot find its way back to its colony, it's dead. So that is what instigated the need for neonicotinoids.
Okay. There were
From can they finish and then after
There's a
finish.
Oh, no. I'm trying to
I want please let them finish the panel. Then
Yes.
you can.
all right.
So thank you very much for coming here to join this discussion panel. We really look forward to your contributions and to the enlightening discussions we will have. I will shortly outline the rules of the game. I will give you one round of questions, and I ask you that you give a short answer, not exceeding 2 minutes. I'm German, and all the stereotypes about Germans are true. So you will see me making hand signs, just to ensure that everybody gets an opportunity to contribute their perspective. I have 2 experts in the audience that I would also like to ask for comments. And we can see that there's already interest in the audience and asking additional questions. And if time permits, we will then come back to the panel for final comments by each of the panel members. As a first step, I would like to shortly introduce yourself, please, with your name, title, and the organization that you work for.
Okay, so Enoch Benchi, and I'm with the University of Ghana.
I'm Emmanuel Ajibatumo, Deputy Chief Executive in charge of Agronomy Quality Control, Ghana Cocoa.
Professor Point from Crop Research Institute of Council for Scientific and Industrial Research. I'm an entomologist.
Good morning, everyone. My name is Ernesto Sesque. I work with the Plant Protection and Regulatory Service Directorate of the Ministry of Food and Agri. My office is the Pesticide and Fertilizer Regulatory Division. I represent the Ministry of Food and Agri.
Honestly. Okay, well, I'll take it back. Okay, so we have some technical challenges, and our apologies for that. I would like to start with a question from Mr. Oseyasibe. And I would like to know whether MOFA has any ongoing or planned initiatives regarding neonicotinoids.
Hello? Okay, so I think that from the ministry point of view, like I said, I work with the Plant Protection and Regulatory Service Directorate, and our policy is of a broader one, that is of integrated pest management, which my directorate is seriously implementing. But on to the specific question, You know, the Ministry of Agri works closely with the Environmental Protection Agency under the Pesticide Technical Committee. That is actually responsible for approving pesticides that are registered and also periodically reviewing whatever list. And unfortunately, EPA is not here, but I think I did some engagement with them before once I was contacted. And my understanding is that, well, in the recent past, there has been some engagement with some conservation groups concerning this particular pesticide. But more or less, what was missing was issues of data to support, especially in Africa or even within our Ghanaian context. So when I discussed with them, I think they were even very welcome to such a discussion and whatever details that will come out of this research. And like I said, whatever information we can generate from this particular research would then be put before the Pesticide Technical Committee for review of these products. Because from the Ministry of Agri, whatever we are doing now is that let me put a particular example of the fall armyworm menace that we are currently dealing with. And what we've consciously done is that even in our procurement of pesticides, because of the tendency of because of most of these issues come out because of large procurements and, like you mentioned, mass spraying exercises. So what we've consciously done is that products that we are approving for use on these pests are actually products that we know we call them biorational or are more of a biological nature and can ensure sustainable production. So from the ministry side, together with our colleagues from the EPA, that is more where our approach is for now. Yeah, thank you.
I would so like to use just one microphone. Can you hear me in the back? Okay. Yeah, this one? Okay. Thank you very much for that. That is a very encouraging information, and I think the lack of data that you mentioned has been reflected in the report as well. There is great research need in Africa, and especially for different disciplines to come together. I would like to ask the next question of Dr. Jamo from Cocoa Board. Dr. Jamo, we've now heard a lot about honeybees, and as I said, they have been studied particularly well because they're easily studied. But we know that bees are not the major pollinators of cocoa, and that cocoa is pollinated by midges. And it seems that midge populations have been decreasing in cocoa plantations, leading to reduced production of cocoa pods, and that perhaps that was the reason why Cocoa Board has instituted this large-scale hand pollination program to address the issue of reduced fruit set. My question is, in the light of the report that was just presented, what are the plans of Cocoa Board to go forward with neonicotinoids and also other insecticides that have a similar mode of action?
Thank you. Let me start by saying that Cocoa Board itself has been following the trend of issues regarding the usage of neonics, what's happening in Europe, America, and other places. And so we are very mindful of the chemicals that we are also putting out there for farmers to use. And like the first presenter said, over the years we have been engaged, we have been using three major insecticide group, let me put it that way: the imidacloprid, the thimetosam, and also acetamiprid. But as we are all aware, in 2001, with the inception of the CODAPEC, Cocoa Pest and Disease Program, it was mainly the imidacloprid that was being used mainly for the control of merits on cocoa. But I must put this information down that since 2017, we have stopped the usage of imidacloprid. We have stopped buying imidacloprid on cocoa. The idea of this hand pollination was not mainly due to the fact that of the reduced numbers of midges, but it was mainly due to the fact that we realized that in our seed gardens, we have used this technology and it's working. And we see a lot of pods on our cocoa every season. That is the hybrid seed pod that we produce and then we give to farmers for planting. So we decided that why don't we adopt this same technology, pass it on to farmers, and then for farmers to do it on their own farms with the hope of increasing yield. The issue of midges population coming down is something that we have not really looked at, because every chemical that Cocoa Board approved for farmers to use go through series of tests, and then Cocoa Research will make sure that they look at the effect of the chemical on non-target organisms. Because you see, in the cocoa ecosystem, apart from the merits and the other insect pests that are of more concern, we also look at the beneficial insects. So before a chemical is passed to be used, we look at the effect of the product on the non-target organisms that are very important in the ecosystem. So if a chemical is very good, it does the killing of the merits, but at the end of the day we realize that its effect on other insects like Ecophila, midges and so forth and so on, we certainly will never allow that chemical to see the light of day. But we are dealing with chemicals, and certainly even the farmer application, the kind of extension application that goes out there, not every farmer will pick it the way that it's supposed to be. So as we speak, there is a strong collaboration between Syngenta and Cocoa Board. We want to look at the effect of thimetosam on these midges. It's something that we're going to look at critically. So we appreciate this study that is going on. And as I said, one, have stopped the use of imidacloprid, which is the trade name was Confidor. Since 2017, we have stopped purchasing. We have never used it on cocoa, and we have also reduced the quantities of other thimetosam, product that we have in the system that we are using, all because we are being guided by the possible effects of some of these chemicals. So we are studying, and then when we get the conclusion of this study that we're just about to initiate, that will give us a fair idea and a firm idea as to how to go about in terms of chemical usage on cocoa. Thank you.
Thank you, sir. So it is very encouraging that there's all this research going on, as I mentioned earlier. And of course, if there is the networking that we mentioned, then all of the institutions and research bodies can benefit from each other's, and also to inform the regulatory decisions that need to be made. Thank you. Dr. Frimpong from the CSIR, can you tell us what ongoing research on neonicotinoids the CSIR is conducting?
For now, CSIR has a lot of agriculture-based institutes, like the Crop Research Institute, Soil Research Institute, Savannah Agriculture, and others. So grappling with pesticide problem has been an issue for some time. But when the neonicotinoid issue started coming from Europe, we had to re-strategize on how to tackle the pesticide problem. So we decided to form a center, what we call the Pesticide Risk Assessment Center, where we can have a common front for all the agriculture-based institutes within the CSIR and look at how we can tackle the issue of neonicotinoid, because most of the crops that we deal with, we need the pollinators, particularly the bees. So we didn't have empirical data to back our studies. So currently, what we have started doing is doing a farmer survey on the extent of application of the neonicotinoids on the crops that we overlook. And also, this might be anecdotal, but very critical. When we started interacting with farmers with respect to the use of the neonicotinoids, the moment we talk about bees, they come out strangely and say, oh, previously, whenever you are going to the farm and you are working on this footpath, we are seeing a lot of bees along the way. But for now, we are not seeing them. So it means, apart from the ordinary insecticide, it's possible that what the Europeans are witnessing is also happening here. But we need to get the empirical data before we can know what to do. Thank you.
Thank you very much for that. It's very important, I think, to collect that empirical evidence and also really to see what's happening in the field and instead of focusing only on lab studies. That is very important. Thank you. Dr. Danchi, you have shown that the residue levels in cocoa beans are not very high and that the residue levels in soils are quite variable. So should we be concerned about neonicotinoids in the environment, and why should we be concerned?
Okay, thank you. So yes, the levels in cocoa ecosystem were within regulatory or allowable limits, and that is good. But definitely we have to be concerned. Particularly because of the mode in which neonicotinoids, their mobility and the way they act, their harmful effects on other non-target organisms. As we've indicated, they tend to have sublethal effects. So sometimes these are seen in the long term, and we may not see them immediately. So sometimes, as Dr. Frimpong was saying, anecdotal evidence suggests that, okay, previously we had this over here, and over a long period of time, now we realize we don't have it. It may or may not be due to these pesticides and so on. But what is clear from the evidence from Europe and elsewhere suggests that we really have to be concerned. And I'm glad that at least the Ministry of Food and Agriculture and Cocoa Board, it's also concerned about this and putting measures in place to ensure that in our quest to increase yields, and we probably may need to use these insecticides, but we ought to ensure that ecosystem services are also protected, because they are key to this. I mean, on the one hand, we're trying to control insects that are destroying our crops. But if in our quest to control them, we end up also controlling or harming other insects that are important for producing these crops, then at the end of it all, we've achieved nothing. So it's important that we be concerned, yes.
Thank you for that. I would like to give the microphone to a guest, Professor Peter Quapon, who has kindly come from the University of Cape Coast, and he has come as a representative of an initiative that is also concerned about pollinators and food security. This is the UN Biodiversity and Ecosystem Service Network, abbreviated as BESNet. And there was recently an Anglophone African trialogue that was looking, amongst others, on land degradation, pollinators, and security. And so, Professor Quapon, I would like to ask you what the BESNet initiative concluded from their deliberations with regards particularly to pollinator protection and pesticides. Yes.
Good afternoon, ladies and gentlemen. As Nina has said, I have come to represent BESNet, which is a network of networks. And we are concerned about land degradation neutrality, and also pollinators, as well as food security. And in May, we had a meeting in Nairobi, and to look at the holistic welfare of pollinators in food security, and also how our lands are being degraded, and if we can reverse that, that's what we refer to as land neutrality. And we know that a lot of human activities help to destroy land, and as we destroy land, we also destroy the biodiversity and key ecosystem services that are linked with this. And obviously, as has been discussed over this meeting, food security as a result of pollinators population being declined. So we have seen all over the world that pollinators are declining. Personally, I have been engaged in pollination work in Ghana and globally since 2000. I've done a lot of research, and I am particularly happy that today NASAC is launching this document, because let me put it to all of us. The fact is that the insects that are destroying our crops are far, far less than those that are helping us. So if we are employing any activity or program to, as it were, destroy the pests, then we should realize that its repercussive effects, negative effect, can affect our helpers, not only pollinators, termites, earthworms, and all other organisms that are in our ecosystem. So best nets bring about science, policy, and also our interaction as to the way forward to this. And at the end of it, 5 countries in Africa came together, and we developed action plans to go into our countries and start some initiative to bring a special education and awareness to our communities and our countries about the importance of land degradation neutrality married to pollinators and food security. And I believe that various actions are going on all over the Africa or these countries, and very soon there will be. We have been receiving feedback as to what is happening in various countries. So far on that front, that is what we are doing. Thank you.
Thank you very much, Professor. Can you tell us which countries have these action plans?
Kenya is one, Ghana is one, Ethiopia is another, and Tanzania, and I've forgotten the rest, unless I check the list. Thank you.
Thank you very much. That is a very encouraging step forward, and it is wonderful to see that so many different countries work together to really address these problems from a broad perspective. Thank you. I would now like to give the microphone to Madame Victoria Dongo, the Executive Director of the Peasant Farmers Association of Ghana. And Madam, I would like to ask you, is the Peasants Association aware of neonicotinoids and of the problems that they are causing for the environment?
Yeah, thank you very much. Yeah, smallholder farmers, especially the Peasant Farmers Association of Ghana, is aware of the dangers of hazardous pesticides on the environment. We are aware of that because we have noticed certain changes, in the farming system, things that have taken place. Just before I came here, I put it on our platform to ask them what they think the the hazardous pesticides will be doing, and they said smallholder farmers are aware of the hazards of using chemical pesticides or whatever. They contaminate the soil, water, and other vegetation. We know that in addition to that, they kill weeds, even birds, fish, and other living things. We have observed the disappearance of toads and whose croaking we sometimes use to forecast rain because of the chemical pesticides. They can also affect non-targeted plants. All this affects crop production, biodiversity, and environment in general. So, generally speaking, yes, we are aware
Thank you very much for that. And thank you very much for that. It is good news that there is this awareness, but it is a terrible story to hear that the effects are really so widespread. And it is good to hear that the awareness is there, but it is terrible to hear that there are so many negative consequences already being observed. But they're not formally documented. So I see a large gap there for science, and it feeds partially into what CSIR is doing in actually collecting data from farmers, also on disappearances and side effects. Tell me, we now heard that MOFA and the EPA and CSIR are doing research to address these problems. How could these institutions help the PFAG and to help the smallholder farmers to prevent unintentional harm to the environment through pesticide use?
First of all, education and awareness creation. But education will be coming through, for example, extension services. And the issue of extension is a challenge. Access to extension, because normally it's the extension officer who gets very closer to, even with research and extension work together. So it's the extension officer who comes closer to the farmers. Then we have an issue with access to extension. But for me, education and awareness creation will help. Because even though we are aware, we don't know the extent to which these pesticides affect, even our agricultural production. We know this is happening. How can we do, what can we do to address it as farmers? And what can the researchers and the scientists help us, to address it? So, yeah, I think that is through education and awareness creation.
Thank you very much for that. I would now like to open the discussion to the audience. So any burning questions that have emerged during, I can see already, during the talk. Do we have another microphone? No. Okay. Sorry? Is there a second microphone? Microphone? Is there a functioning microphone?
There's one there.
That one also barely works. What is? Okay. Coming.
Hello.
Just one.
Thank you very much for the good work done. And I would like to find out some clarification. In page 35 of the book launched, is stated that the last paragraph, particularly against the background of high exposures due to over-application and misuse of neonicotinoids in Africa, these uncertainties and lack of data mean that effects beyond those on pollination and other ecosystem services extending to other wildlife and human health cannot be ruled out. However, when I listened to Denchi, he was able to convince us that as far as cocoa beans are concerned, it is within the threshold. So I will be very happy when such statements are substantiated in order not to be a blanket statement. My next observation is Enoch Denchi was doing insecticide for diplomacy, which I didn't like, in the sense that cocoa sales in Ghana, they put aside some monies for scholarships, for taking care of the cocoa trees and others. But an impression has been created here that the government sprays the cocoa free of charge, which is not true. Because out of the sales, that monies have been set aside to take care of the cocoa beans. And lastly, in the book, page 53, Denchi said he's at University of Ghana. But in the book, he is a member or a fellow of Ghana Academy of Arts and Sciences, which I think need to be corrected. Thank you.
Thank you for these inputs. Enoch, would you like to respond?
Yes.
So thank you so much for the very good comments. Well, the very first one, in relation to my presentation and what is contained in the book, I must clarify that in my case, I presented the situation for Ghana. And the book, this report, it's from a number of African countries. So it looks at not just the situation for Ghana, but for all other countries concerned. So if in this particular case where in cocoa ecosystems, and I did mention that, so for instance, when you take the cocoa, within the NEPs, the levels are within regulatory limits. But it wasn't the same for the shells, which are usually not consumed. Again, we saw that the levels in the soils were high, in some places. But like as I've emphasized, this report is for Africa, not just the Ghanaian case. Now, the second point is the fact that mass spraying and so on. What I indicated in my presentation is that there is no direct financial cost to the farmers. So to the farmer, it's pesticide that is being given to him or her for free. At that point that they are receiving the pesticides or it's being sprayed on their farms, they don't have to pay for it. Whether government takes money from the cost of the beans and then puts it aside to do that, or otherwise to the farmer at the point of receiving the pesticide, that they don't have to pay for it. And that was the point that I'm making. Again, I work with the University of Ghana, but based on this report, it was put together by the academies of arts and sciences in Africa. And I represented the Ghana Academy of Arts and Sciences. So within this report, I was coming on behalf of the Ghana Academy of Arts and Sciences. So thank you.
Thank you. In one and after the other. Yeah. Okay. So I'm going to collect 3 questions, and then we'll have responses to them to just reduce the running around.
Okay.
Yes.
Mine is not a question, but just information coming from a colloquium that the Ghana Academy organized several years ago on the relevance of tradition in contemporary Ghana. The final session of that colloquium was addressed by a woman who had never been to formal schools, but had become a very highly recognized traditional healer in the northern part of this country. She was asked a question about how we could provide guarantees for what? The continued supply of what? The plants that she was using for her treatment. She said something that shocked all of us. She said the real danger was coming from the pesticides and the fertilizers that we were spraying all over the place. That they were weakening the strength of the natural ingredients in the plants. And that's what we should watch out for. That she was having difficulty getting plants today that would be as effective as they used to be from places that had been sprayed by chemicals and pesticides. And I think that this information, so the point about non-target organisms, we should be keeping this also in mind, that our traditional healers also are having difficulty with them.
Thank you very much for this contribution. Let's try that one.
My question goes to the gentleman from the Ministry of Agriculture. We have heard about the cocoa industry and the danger that is potentially likely with the use of neonicotinoids. But we have other crops that are equally suffering. When you are going to Professor Ite's village, just about 5-10 years ago, along the road, you would see huge plantations of mango trees bearing fantastic fruits. Then the mango mealybug problem came in. And in our attempt to solve that problem, the mango farmers are now complaining that yields are going down. Is the Ministry of Agriculture aware of this? And if so, what is being done to increase yield whilst at the same time protecting the plants, protecting the environment from the effects of whatever pesticides they've been using?
Thank you. I will collect one more question, if that's okay, and then then I'll come back to the front.
Thank you. I think that the effect of
Say what?
This one.
Yeah.
The impact on the environment is very clear.
I need to keep using this one.
From here, where are we heading? Are we heading towards a phasing out of neonicotinoid in Africa? Or are we looking eventually to ban the neonicotinoid and replace it by... Should I repeat again? Yes, I am just seeking clarification regarding the way forward from this study. We find it's clear that the effect of neonicotinoid has a negative impact on the environment. But from here, where do we go? Are we advocating a phasing out of neonicotinoid in Africa? Are we going towards a ban of the insecticide? I would like to ask the panel their views about this.
Can you give me the blue one again? Thank you. So, to respond to the first question?
Hello? So I think that with the question about the mango industry and then its myriad of problems, I think that I want to give the assurance that the ministry is actually engaging the players in the mango industry. Even though this forum was not for that particular theme, but I can give assurance that issues with mangrove fruit fly, the BBS issue, are being really looked at. I was part of a study that was recently done to even evaluate products that are on the market that farmers were using. We've just finished that study and trying to even engage industry to come out with, because what was missing was that we're not really having effective products that were specific for, let's say, the bacterial infections and all that. So on that level, I would say that there's a lot of engagement that is going on. We have met, and the ministry also advised that they come together under one umbrella, because we found out that they were all having different issues and trying to engage the ministry from different angles. So what we've essentially done is to let them all be under one umbrella so that we can engage them directly. But all these various issues you talked about, that is leading to the decline are really being looked at, because it's actually, as you said, it's also having an effect on even the exports of these mangoes to outside. So it is something that MOFA has engaged them, and then we are trying to work on them with them to find an amicable solution to. We even have other collaborators that are also assisting. GIZ and PTB are also in that same regard assisting Ministry of Agric in trying to solve this problem. Thank you. On the either forward. Oh, maybe you can touch on it first. No, let me touch on it. Okay, let me. I thought you were going to say first. Maybe we could come to. Okay, maybe so. In terms of going forward, I think in my initial remarks, I did mention that from where we sit, together with the Environmental Protection Agency, that is actually the national regulator of pesticides in Ghana, we are welcome to such data and information that will come as a result of this research that is being conducted. What I'm aware of is that Ministry of Agric and even the EPA sometimes support certain studies to bring so that we can make better informed decisions. A case in point I can put is probably even issue of atrazine in maize production and all that, where research was supported to try and find out whether contamination of underground water within our particular context was something that we should look at, probably phasing out atrazine from the market. So the issue of neonicotinoids is one that has also come up, and it is something that we will engage the scientific community. And I'm very happy to also have heard that other research are also currently ongoing, and we'll be happy to engage all those stakeholders so that whatever decision will be taken, either it will be a complete ban or restricted use or whatever, would be on really well-informed decisions that we will take. Yeah, thank you.
Thank you. What I will add to it is that, as I indicated during my, Cocoa Board is fully aware of the trend of issues. That's why I said, first, in the first place, 2017, at the inception of Kodapec, it was imidacloprid that we had at the time, and a few other products. Since 2017, we have stopped the usage of imidacloprid on cocoa. And we have also reduced significantly the intake of other thimetosal products that we have in the system. Why are we doing this? It's all because we're looking for alternative, environmentally friendly sort of products that can really take care of the challenges that we are faced with. And so we're working towards that. We're looking at other novelties that we have in the system that currently we are trying one or two products at Cocoa Research. But then we still have to look at the possibility of the effect that they're also going to have in the future on these same non-target organisms and other environmental issues. But the point I want to make is that Cocoa Board is fully aware, and we are very careful and mindful of the product that we are releasing into the system to make sure that we are able to stabilize the system until we get good alternative that can replace. We are almost there because we have reduced the intake of the neonicotinoids. So we have just a few that we are still dealing with, about one or two that we are still dealing with, but the goal is that we'll certainly do away with them. Thank you.
Thank you. I believe there was at least one more question. Yes.
A brief one. Neonicotinoids versus some naturally occurring insecticides, such as pyrethrins. Could you just address that in terms of efficiency, effectiveness, and persistence and comparison? And therefore, do you feel that really the direction we should be moving towards is looking for naturally occurring insecticides?
Thank you.
Thank you very much. I think this escaped me, but thank you for raising this issue. Yes, Cocoa Board, one area that we are also pursuing
vigorously is looking at organic production of organic cocoa. And so we have a number of organic products that we have in the system now that, in fact, if you look at the recent purchases that we're going to make this season, we have included all that so that we can buy organic insecticide, botanical insecticides for usage. So that's also another area. So the whole idea is that while we are reducing the intake, we are also increasing the purchase of the organic insecticides to make sure that in the end, that is where we want to go. So yes, like the product you mentioned, the pyrethrum, we have some in the system that we are working with now. So exactly, that is what we're doing now. Right.
Just to add on that, similarly, that is what the approach that the Ministry of Food and Agriculture has also taken. That even in we are also currently doing some form of procurement for against the fall armyworm, which within the last 2 years was causing a lot of menace in our maize production field. So if you look at progressively, our shift has been from the inorganics to now going to organic products, where we are procuring neem extract products. Pyrethrum is being added to this year's procurement because there was a series of field work that was done and has shown promise. So we have added pyrethrum to it, and then we have also other products. Bipel, Bacillus thuringiensis, it's also hold a lot of promise against these caterpillars. So all these are progressively in our bid to encourage sustainable agricultural production, whereas we also put in resources in encouraging biological control processes, which the plant protection is also engaged in. Thank you.
Thank you. Are there any more questions in the audience? One? I think one last. We'll take. Oh boy. Okay. We'll start here.
Yeah, in this report, they say that it's important not to divert limited resources available in Africa to repeat European research. So the question is, we should do enough research to make decisions. So I'd like you first to comment on that. Are you really going about in that kind of approach, or are we trying to repeat the research done by Europeans, or do you think that's the right statement? Then the second thing is, given that, are there really economical alternatives, like for specific crops like mango, cocoa, or are we just, thinking, like maybe also get to the European experience? How have they replaced the neonicotinoid insecticides in their areas, and as well from Ghana or from other African countries? What are the alternatives, and are they economical? And the final thing, and what do you think is the consumer going to think? If they're going to consume their chocolate, don't you think there's a limited time? You have to act fast.
Thank you. Can I take one more questions, and you memorize the first 3 questions? Yes?
Yeah.
Yeah.
Naturally occurring pesticides. I'm aware that there have been at least 3 major conferences or workshops on the use of the neem pesticides, neem insecticides, sponsored by GAAS. These neem insecticides are being used extensively in Burkina Faso for their vegetable production. Work has been done at the University of Ghana. I've been involved in it. Work has been done in the University of Cape Coast. Professor Tayman has been involved in it. I'm surprised that up to now, the Ministry of Agriculture does not seem to have realized the importance or the usefulness of the neem insecticides. And neem trees are growing all around us in this country, especially in the Greater Accra region. May I know from the ministry people to what extent they have looked at these other alternatives And I know that in the northern regions, some of the millet and sorghum farmers use the neem seeds in their raw form. But to what extent are we formalizing the use of these natural pesticides?
Thank you.
Okay, I think I did mention, even in my last submission, that even in our quest to control this fall armyworm menace, it's one of the products we have taken on board and are procuring, because the fact is that for me, from what we said, is also with the investment that is going into the sector, and what all we can do is to encourage personnel or persons who be interested in going to producing or mass producing these pesticides, and support them with the necessary policy, because as you are aware, it's also capital intensive and also very labor intensive to then produce it in a very large scale. A typical example, a case in point, is last year when a contract was given to these local producers to supply these neem extract products for control of fall armyworm, and a lot of them could not even supply the quantities required, because with these biologicals, the issue is that they break down very quickly, and you need to probably apply more than the conventional products. So all those things, we have to look at it at the pros and cons and see how progressively, with the right education, we can educate farmers on using these other biological products as an alternative. But having said that, I think the issue of misapplication is also one of the key things, even for the conventional products that we are using. And I'm happy that our peasant farmers are represented here. That it's something that the ministry is consciously always educating our farmers and building the capacity of our extension officers. But it looks like a lot more steam to be done. And our farmers, for some reason, are also still sticking to their old ways of doing things. So sometimes that is the issue. I believe that if we would also follow sometimes the manufacturer's instructions of pre-harvest interval and other things, we would not necessarily have a lot of residues even in the products that we are producing. So that's from the ministry's point of view. Yeah.
Okay. I briefly want to add something to it. In fact, with respect to the use of the organics or natural organic insecticide, I think one critical aspect we have to look at is reorientation of how farmers perceive the mode of action of insecticides. Most of these farmers, as at now, they want quick or rapid knockdown. So if you apply insecticide and it's going to take some time before it acts, to them, that insecticide won't be effective. So there's the need to reorient the farmers as to how this insecticide works and the benefits that we can derive from them. If you are to go by that, I think we can make some headway.
So I'm afraid we've actually run out of time, and you probably are already all quite hungry. If you're interested in continuing, please stay back, and you can maybe ask a couple more questions of our kind panelists. But in the interest of sticking to the schedule, I would like to thank our panelists and our experts in the audience very much for coming here and for these interesting and enlightening discussions. Just 1 second, yes, yeah. And on behalf of all the experts and organizations that were involved in producing this report, I hope that this will be a useful resource and that it will help to inform both scientific inquiry and policy advisory work, and help to address the balance between increasing agricultural productivity but doing it in a sustainable way that takes care of the environment. And with that, I would like to give the word back to Professor Sefarede for the concluding comments.
Thank you very much. When we started, I mentioned that food security is a complex area. And this morning we have just dealt with just a few aspects of it from the presentations this morning and the very exciting discussion that we have just added on. It's another end of the food systems where you want to improve efficiency and improve quality and health of your consumers. Indeed, science academies, in collaboration with states and private groups, such as our colleagues sitting here, I see representation from different institutions, all working towards, I would say, the same goal. If we could do more of this, it will help our nations to make progress very fast. And therefore, on behalf of all the speakers this morning, the Ghana Academy and NASAC and all the organizations involved in this AMASA meeting, I would like to thank you for your participation this morning and for being such a good audience. Thank you. All right.
Thank you, Paul.
Now, I need all of you gentlemen who are working
Excuse me, we are going back to the golden plate for lunch. It's